Hello everyone, thanks for joining today's Tech Talk. We'll get things underway. Appreciate you all joining. My name is Ryder Morton. I'm the Business Solutions Manager for our Nature Tread space here at Treadwell. And today we are going to unpack the case study on the Cathedral Fig Tree Boardwalk. So just an introduction into the Nature Tread space at Treadwell. So we are a supplier of FRP or fiberglass reinforced plastic products. And the Nature Tread space tackles everything public infrastructure related. So that can involve boardwalks, small pedestrian bridges, coastal access structures like staircases, access ramps, and the likes. And one of the key projects that we've delivered in the past we'll unpack today. For those that might not have joined our previous tech talks or are new to the world of FRP product, FRP stands for fiberglass reinforced polymers, and it's a composite material made of a matrix arrangement. So your glass, a variety of glass reinforcement, acts as the product's strength component, and it provides the product's shape. The resin, which Treadwell integrates a thermoset polymer, comes in a range of resins. We primarily stock the isophilic and the vinyl ester resin systems, known as our I series and V series. We also integrate additives such as fire retardants and UV inhibitors that are ideal for the Australian conditions and the harsh conditions that we have in this country. So the benefits of FRP, as many of you are probably aware, the product is corrosion rust rot proof. No protective coatings are required with the material, as opposed to traditional components like timber and steel. Long-term cost benefits without the requirements of maintenance over time. Our products don't require any hot works or welding permits or anything like that. Is also non-conductive and has a very lightweight to high strength ratio. So FRP boardwalks, they're, I would say, the main project scope within our Nature Tread brand. So boardwalks obviously designed and built to protect environmentally fragile or sensitive areas within the country or across the globe. So we actually offer a suite of standard designs that have proven effective in various applications or project conditions. These are our Brighton and Waterfall series boardwalks. So we have completed general arrangement drawings that are essentially pre-engineered. They won't obviously work for everything. We have unpacked this on a previous tech talk, so feel free to check out the recording link on our website if you missed that one. So project in question today is the Cathedral Fig Tree. So it's located in the Atherton tablelands of tropical far north Queensland. The fig tree sits deep within the Danbulla National Park and State Forest, and the assets and project scope is handled by Queensland Parks and Wildlife Service. So the sheer size of this tree is pretty breathtaking. Having visited it last year myself, it's approximately 50 metres tall, and its crown spreading over 2,000 square metres, equivalent to 2 Olympic swimming pools. The fig tree is estimated to be around 500 years old, so heritage listed. It's obviously got a complex and sensitive root system, not only on the ground, but also in the branches. Conservation of this significant tree was a crucial factor that needed to be considered by Queensland Parks. So Cathedral Fig Tree Boardwalk, as you can see here, it's during installation, contracted by Dawson's Engineering, company located in Cairns, that have installed numerous Treadwell projects over the years. Everything fabricated, installed with bolted connections was done on site using manpower and hand tools, battery tools. So post-install of the boardwalk, beautiful elevated system providing safe tourist and visitor access without damaging the tree's sensitive root system. Unpack it in a jiffy. So, as I mentioned, installed in 2017, this boardwalk has been in place for 8 years now. It's designed for a 5 kPa UDL distributed load with a 4.5 kN point loading. It's mostly 1800 mil wide with suitable wheelchair access. There's 2 photo/viewing platforms integrated within the design. Treadwell's scope was design and supply of this structure. So we provided the engineering and shop drawings, provided to contractor Dawson's in this case to complete the installation. So the products that we used on this particular project, range of FRP profiles. So the Architect's wide flange beam, or as some of you may refer to as H beams, 203 by 203 beams, almost 10 mil thick as the bearers. The square hollow sections 100 by 100, 10 mil thick as the intermediate joist, and a FRP grating mini mesh product or the decking component. We also used FRP brackets, so 76 mil equal leg angles for the majority of the connections with stainless steel 316 bolts. Timber kick rail or curb rail on the left-hand side, and then the right-hand side facing the tree was a timber handrail with powder-coated infills. So we're open at Treadwell to use hybrid systems for aesthetic purposes in this scenario. For the footings of the Cathedral Fig Tree, it was a concrete pad or plinth that simply sat on the ground. So as with all FRP installation and fabrication, simple power battery tools were used to fabricate all these components and assemble the boardwalk structure. Our chem-set anchors were used to bolt the bearers down into the concrete plinths. So some of the challenges with this job, protection of the existing landscape, particularly the root system of the fig tree, was a major challenge. High volume of visitors around the worn-in path originally posed risk to the tree's health and long-term considerations. So an elevated boardwalk solution was required in the long run. So there was obviously going to be some difficulty in laying out footings, being a challenge that needed to be considered alongside other logistical factors. If we were to say steel to be used on this boardwalk, that would require most likely heavy machinery, modular transportation, potential on-site welding, and pose a corrosion issue in the following years, sitting in a humid, damp environment as this rainforest environment. Using timber alternatively for this boardwalk structure would have posed a maintenance regime and long-term rot issues sitting in this rainforest. So unpacking the solution we offered, FRP obviously comprises of lightweight characteristics, similar to the weight of timber. So 2 people lifting and transporting means a low impact installation methodology. And all connections being bolted means that this structure can actually be demodularized if ever required, or say a branch was to fall and ever provided any damage to the boardwalk, it can be demodularized and remove that particular piece. So the plinth footings were a major solution here. So from a soil/root conservation perspective, simply laying the blocks on the surface removed any damage risk with other driven or over that of using a driven or screw pile arrangement. This also adds to the modular boardwalk format. So we also offered an FRP grading here. So if many that have used the decking prior, they understand that it comes with an anti-slip finish. Means the highest level of slip protection is offered with a P5 and R13 slip rating with this FRP grading. The structural beams and grading made of a premium glass and resin matrix means that no corrosion, rust or rot poses as an issue for the governing body, being Queensland Parks. We anticipate the structure to withhold its case-proven and issued 50-year design life of this structure. So 8 years on, some photos on visiting it last year. From original install in 2017, Boardwalk is looking better than ever, with foliage and elements of the rainforest growing around the subtle structure, with perhaps an inspection or two of the bolt connections. This is the ideal and maintenance-free structure for the end client, Queensland Parks. So minimising costs in the long run without requiring material replacement and ongoing costs. We expect this to be in place for many, many years to come. We're thrilled to be part of such an iconic tourism project location. We look forward to future and similar jobs of this nature. We are more than happy to assist with design, supply and any general questions surrounding FRP and the solutions that can be offered. I will just touch on a few more Boardwalk case studies briefly, but feel free to pop any questions you might have on this case study within the chat, and we'll aim to review them. So a few other Boardwalk case studies, won't spend long on these, around the country that we've done, include the Arno Bay Boardwalk, Council of Cleve. This was installed within sand dunes, used a shorefoot footing, like a micropile, and our FRP structure was installed on top. Another project we completed for the Queensland Parks team on Whitsunday Island, part of the Naro Trail project, involved a mangrove sitting FRP boardwalk and a 15-metre clear span bridge made of FRP beams also. The recently completed Whitten Bluff Boardwalk for City of Onkaparinga in South Australia. This was a elevated structure, as can be seen, using FRP framework and posts and a stainless steel balustrade. For the City of Gold Coast, we completed the Burleigh Heads foreshore at Tallabudger Creek, another iconic location using a very similar to the Cathedral job, low-level structure sitting on concrete piers and an FRP deck and handrail. The Beach to Beach or Dunbogan Boardwalk for Port Macquarie's Hastings Council in New South Wales, completed just over a year now, which sat on steel screw files. Feel free to pop any questions onto the chat. Looks like we've got a few coming in. The approximate cost per square metre for the boardwalk construction. Good question. On the Cathedral Fig Tree, it was 2017. So while costs of FRP don't fluctuate as much as the traditional materials like steel or timber, I can anticipate it would have been around the 500 to 600 per square metre for the structural framing. What type of footings used for the boardwalk? So obviously in that particular scenario for Cathedral Fig, just simple, I believe they're around 500, 400 deep concrete blocks that simply sat on the ground. Any other questions, feel free to post them in the chat. I just got a question coming for clearance requirements for micropile footings. So just on that, Treadwell don't specialise in any sort of civil or footing requirements. We generally will leave that to the civil designers. However, particular case studies like Arno Bay, I'm sure you're referring to, we can take that offline and send a separate email for that particular case study. Well, thanks everyone. I appreciate you all joining. We'll send an email out. If there's any other questions that do come in, we'll be sure to get a response to you. Thanks all. Appreciate your time.